All right, welcome everybody. So let's do this. So let's go with question 3 and question 4 over here with the chocolates and the probability. Okay. So just some notes for us to review. We really got to make sure we're okay with the idea of mutually exclusive and not mutually exclusive. So here, just as an example, like rolling a die and receiving a 4 and a 6. If I roll a die, can I get a 4 and a 6 at the same time? No, not possible. But can I roll a die and receive a 4 and the even? Yes, because if I roll that 4, it's even. All right. So just for the nice example that we have in class, if a person is a Democrat, let's say the person is a Democrat, the person is a Republican, the person is a Democrat and a Republican. This is not possible. You're either a Democrat or a Republican. You can't be both. When this happens, we say the two events are mutually exclusive. Okay? Like if the person is a female, the person is a Republican, the person is a female and a Republican, this is okay. You're allowed to have this. So this is not mutually exclusive. All right? So the two formulas we have for mutually exclusive and not mutually exclusive, this is for mutually exclusive, and this is if it's not. So let's just look at the first question here. The probability of picking a diamond. Okay, that's pretty straightforward. How many diamonds are there? There are 13 diamonds, and there are 52 cards in a deck. So it's just 1 over 4. Okay, easy peasy. The probability of picking a 4 or a king. So let's think about this. Is this an example of mutually exclusive or not mutually exclusive? Can I pick a 4 and it being a king? No. So this is mutually exclusive. They cannot happen at the same time. So the formula we'll use is P of A. The chance of getting a 4 is 4 out of 52. And the chance of getting a king is P of B is 4 out of 52. So what this formula is telling us to do is to get a 4 or a king, we just add these two. So it's just 4 over 52 plus 4 over 52, and that is 8 over 52. Okay? And this should be 2 over 13 when we simplify it. Okay? Not too bad. So the probability of picking a 4 or a red card. Now here, let's see. Is this mutually exclusive or not? Can a 4 also be a red card? Yes. Thus, it is not mutually exclusive. So the chance of getting a 4 or let's say a red, so 4 or a red card, well, okay, so we need P of A. What is the chance of getting a 4? It's 4 out of 52. There are 4 4s in a deck of cards. What's the chance of getting a red? There are 26 red cards, right? So if there are 26 red cards because there are 13 diamonds and 13 hearts, then we have to add these two. But what this is saying, we need to subtract all the 4 red cards. So how many 4s are red? There are two reds that are 4. So we have to subtract 2 out of 52. So then this just becomes 4 plus 26 is 30. 30 minus 2 is 28 over 52. And if what's the greatest common factor? It's 4. So this is divide 7 over 13. Okay? And there it is. What's the probability of picking a black ace? How many black aces are there? There are 2. So it's just 2 out of 52. Or 1 out of 26. Okay. Not too bad. Let's move on. And we go for question 4. Before we do this question about the chocolates and the Snickers and stuff, let's just go over our notes on independent and dependent. So if I draw a card from a deck, and getting let's say if I draw a queen, right, and putting the card back and getting a second queen, what's the chance of that happening? So if I have a deck of cards, if I get a queen, the chance of getting a queen is 4 out of 52. If I put the card back, the chance of getting another queen is still 4 out of 52 because I put that card back. But if I have something a dependent event would be drawing a card, getting a queen, not putting the card back, and trying to get a second queen. If I wanted to pull a card out of the deck, the chances of getting a queen is 4 out of 52. But because I didn't put the card back, sorry about that. Because I didn't put the card back, now there are only 3 queens in the deck, and there's still one less card. So this would be the probability over here. And what we would do in the case of a dependent event, we would have this formula here. Okay, this is for dependent, and this one would be for independent. So all we need to do is just multiply the probabilities. And here we need to multiply, well, we'll get to what this is. Okay? All right, let's take a look at the actual question. So, what is question 4 saying, right? Let me pull this out real quick. So if we have a bag, let me fix this. All right. Is this very glary? Okay, not too bad. So if a bag contains chocolates, right? We have 3 Snickers. Okay, so 3 Snickers, 5 Hershey's, 6 Kit Kats, and 6 Milky Ways. Without replacing any of the chocolates back into the bag, what is the probability of these events happening? So let's take a look. Selecting 2 Snickers. Well, first thing we need to do is, hold on, let me fix the camera. Okay. So what's the total amount of chocolates? It's 12 plus 5 is 17. This is 20, okay? So what's the chance of getting 2 Snickers? Well, the chance of getting the first Snicker is 3 out of 20, right? And now if I were to get, so if I have in a bag, if I have 3 Snickers and there are 20 chocolates in total, how many chocolates are there? And the next time I put it in my hand and get a chocolate out, it's going to be 19. But then one of the Snickers was taken out. So then this has to be 2. There are only 2 Snickers left. So then if we multiply this, let's just multiply this real quick. So the numerator is 6. What's 20 times 19? Is it 380? Yeah, I don't need a calculator. It's 380. Okay? And if we divide this, this is 3 over 190. Okay? So this is the probability of getting 2 Snickers in a row. What's the probability of getting a Snickers then a Hershey? Well, there are 3 out of 20 Snickers. And then how many Hershey's are there? There are 5. But now we have 19 chocolates because we took out a Snickers from the original. And this is using this condition over here. Okay? All right. So here, this will be what? 15 over 380. And divide this by 5, we get 3. And what is 380 divided by 5? And it's 76. Okay. So then bam. That's our probability. What's the chance of getting a Milky Way then a Kit Kat bar? A Milky Way is 6 out of 20, so it's just 6 over 20. Then a Kit Kat bar is another 6, but it should be 6 over 19 because we took out 1 chocolate. Our total right now is 19. So this just becomes 36 over 380. And what's the greatest? Well, let's see. We could do this, 18 over 190. And then 9 over 95. Can I simplify this more? I don't think so. 9 over 95. Okay, so that went over question 3 and 4. Hope that helped. I'll do the next 2 questions in the other video.